Ready to explore some advanced concepts? This video will explore two powerful joins, natural and lateral joins. We already know that SQL joins combine data from multiple tables. The mechanics of joins in Snowflake are similar to Postgres. Here, we'll focus on natural and lateral joins. First, let's recap the pizza database we've been interacting with. Here's its schema diagram. Pay attention to the different relationships, such as the one-to-many relationship between the order source and advanced concept tables. This video will explore two powerful joins. Let's explore natural and lateral joins. Unlike standard joins, we already know that SQL joins combine data from multiple tables. By automatic mechanics of joins in Snowflake are similar to Postgres. Observe the syntax displayed. We'll focus on natural and lateral can also be combined. First, outer join. Let's recap and notice there is no on clause in this join. Let's understand why. In a standard join using an on condition, we might get duplicate columns. For instance, pizza type ID could appear twice, with the second labeled as pizza type ID2. Natural join avoids this by automatically matching same named columns across tables, such as pizza type ID, eliminating duplicates and the need for an on clause. So, it's convenient for quickly matching columns with the same name between tables without explicitly stating the matching conditions. Even if we try to specify on condition with natural join, as shown here, we will get a syntax error. As usual, we can use where to filter the results, as shown in this example. Next, let's examine lateral joins. It's a powerful SQL feature that brings more flexibility to our queries. The lateral keyword allows a subquery within the from clause to access columns from a preceding table or view. So, when we use lateral, the right-hand subquery can reference columns from the left-hand table, making our queries more dynamic. After select statement, add the keyword lateral, followed by subquery. We'll clarify this with an example next. Here, we're pulling data from two tables, pizzas and pizza type, using the lateral keyword. This allows the subquery to reference columns from pizzas. For each row in pizzas, the lateral subquery finds a matching pizza type ID in pizza type. The where clause handles the joining. Notice we don't need to include the join keyword. We need to alias after using lateral, or we'll get an error. So, why not just use a join? While a join could do something similar, lateral is more flexible in scenarios where we want the right-hand subquery to perform more complex operations dependent on the left-hand table. In this example, we use lateral to pair orders with a subquery that calculates the total cost for each order ID. We could get the same result with multiple joins, but when working with large datasets, using multiple joins can significantly slow down the query, thereby increasing computational costs. We'll dive deeper into cost-saving techniques in upcoming videos. The power of lateral is broader than this case. It opens the door for more complex queries, though we won't cover every application in this course, like usage with the flatten function. It's time to advance our hands-on skills with exercises. Good luck!